Hello and welcome to the CytoCave live demo. It starts off with the default coordinate system, an isomap coordinate system in both views, and the two views are independently navigable. You can select different coordinate systems in each view. You can choose from pre-computed coordinate systems that are isomap random trees or t-SNE. And the spheres represent proteins, and that glob of spheres represents all the proteins. And this cloud of cubes represents all of the drugs in the drug interaction network. So we can do a search and search for a drug of interest, nilotinib. And there it shows up, it flashes red, and it shows all the edges that connect to that show its drug-drug interactions and all the drug-protein effects. And on the left, all the drugs are collapsed into the center, into the cube at the center, with all the spheres surrounding it and the isomap coordinate system representing the proteins. You can make them a little smaller. You unlock all of the little locks so that you can control the sizes of the glyphs independently in each of the coordinate systems, or each of the views. The center cube is all the drugs, and all the edges show the proteins that are affected by that drug. We can hover over the different nodes and their names will appear in the bottom left corner info panel and also in the label. So there's CDK4. You can see that CDK4 is a target protein of nilotinib or a side effect protein of. Now PARP1, that one's not affected. We can search for another drug, bozotinib. So now we have two drugs in the drug network, and there are more edges that extend out of the central cube out to all the proteins in the cluster, the isomap cluster. Those two flashing red cubes represent the two drugs that we have selected. I'm going to adjust the sizes a little bit to see the cube a little better. It's also useful to have the same coordinate system on both sides. So now we select t-SNE on the left and the right. See, we have the node degree on both sides as the color code. Now we can unlock the color coding, so we can change the left color coding or to be different from the right. So we can set that to t-SNE so it's the same as what's on the coordinate system set to. So now you can see that there's coherent clusterings visible in the drugs. You can also select the Louvain clustering, which assigns cluster memberships independently of the coordinate system based solely on the connectivity rather than having to have the coordinate system calculated first. And so on the right, we can set that to t-SNE, and we can see how the Louvain and t-SNE and DB scan clusterings, cluster assignments compare. We can zoom into the protein interaction network and have the drug interaction network in the background and explore the proteins and make the spheres a little smaller to see the edge connections better. And compare the Louvain color coding with the t-SNE DB scan color coding. The edges are displayed based on the connection, the interaction strength. So increasing the threshold won't display an edge unless it's of a higher interaction strength. So you can slide that interaction threshold back and forth to display more or less edges. You can also uncheck the intergroup or intra-group edges, and so you can focus on either just the protein interaction network, as we're doing here. We turned off the intergroup edges so that we're not bothered with the clutter of the protein drug interaction network interactions. So we can just look at the protein interactions or just the drug interactions, and turn all the edges back on, and then turn off the intragroup edges to focus on just the intergroup edges and see how the drugs affect the proteins. Now, and just look at the drug protein interactions, how the drugs affect the proteins, which proteins the drugs affect, and which drugs affect which proteins, which proteins are affected by which drugs. That's what we're looking at with those edges. You can turn all the edges off if you can turn both of those off, or turn them both on to see all the edges. You can adjust the opacity of the edges so that they're more translucent or more and don't obscure one another. You can see them better, and you can see which nodes they point out better. You can also toggle the clusters themselves. The entire group of nodes in the same cluster can be toggled to translucent or transparent state, and then back to fully visible. That was module number 2 that we were toggling the visibility of. You can also toggle all of the nodes, and you can toggle all of the nodes to a translucent state, for instance, and then if you want to just have the module number 2 stand out against a backdrop of translucent nodes, you can toggle all the nodes and then toggle the translucent node one more time so that it's fully visible. There's also the sunflowers that are automatically dynamically generated based on the module membership information of the nodes. So the coordinate systems are drawn in a sunflower pattern, where on the faces of a platonic solid with enough faces to cover the number of modules. The Louvain modules membership is represented by these sunflowers. You can they're still colored in T-SNE, so the colors aren't coming through. Now that the Louvain is both the color coding and the sunflower coordinate system, the modules are really identified here in as these sunflowers on the faces of the platonic solid, and the edges show their connectivity. So yeah, there's a lot of exploration that can be done with this CytoCave tool. Thanks for watching.